Welcome back. In video 10, I talked about how many SAT and ACT math questions don't deal with studying or memorization. Instead, they deal with algebraic thinking. Let's take that to the next level now. How to build a let statement. This is a very popular topic on both tests. It has applications in algebra, geometry, and trigonometry. Just like algebraic thinking, it's not so much studyable as practicable. So let's get some practice. We'll start easy, and we'll get harder as we go. If you find this video helpful, please hit the like button, share, and subscribe. Also, leave a comment down below with any questions you have or topics you want to see me cover in future videos. And be sure to hit the notification bell so that you could be updated whenever I post a new video. I really appreciate it. Thanks. Here we go. So let's start a little easier. Jessica has a certain number of dogs. If Matt has 3 fewer than double the amount of Jessica's dogs, how many dogs does Matt have? Think about it a moment. So this is where setting up a let statement is very helpful. We let different terms have variable names. So what's a really great name for Jessica's dogs? Well, they're dogs, so let's let the number of Jessica's dogs be D. Now from there, what's a great name for Matt's dogs? We can use whatever variable we want, M, Q, Z, whatever, but the point of a let statement is to use the same variable for all of the terms. So remember, Matt's dogs are 3 fewer than double Jessica's dogs. So if we call Jessica's dogs D, a really great name for Matt's dogs would be 2D minus 3. This way, they have the same variable. And this is the point of a let statement and every other question we will see in this video. It's all about taking different terms, but giving them the same algebraic name in terms of the same variable. Let's see how it appears on a question. A certain number of sophomores and juniors stayed after school to help repaint the cafeteria. If 6 more juniors than sophomores stayed, and 38 people stayed in total, how many sophomores stayed? Press pause, give it a shot. So let's think about what name we can give the sophomores. If we let the sophomores be S, sophomores, why not? Then what name can we give the juniors? Remember, there are 6 more juniors than sophomores. So by calling the sophomores S, we can call the juniors S plus 6. That's much better than using different variables. So if there are 38 people total, we could say the sophomores plus the juniors is 38. But in place of J, let's call that the new name S plus 6. S plus S plus 6 equals 38. Notice how that expression is one that you could solve because we only have one variable. And now combining like terms, 2S plus 6 equals 38. Subtracting the 6, 2S is 32, so S would be 16. There are 16 sophomores. Let's see how this same concept can come up on a geometry question. I won't even make you solve. Let's just try to set up the equation using a let statement. The length of a rectangle is 4 more than 3 times the width. If the area is 77, come up with an expression to solve for the width. Take a moment, give it a try. So we can call the width W for width, and we could call the length L, but it's far better to call the length 3W plus 4. That way it means that it's 4 more than 3 times the width. And now we can use that in the expression for area. If area is length times width, we could say length times width is 77, but then substitute in 3W plus 4 times W equals 77. And I won't even make it go any further to solve, but the point is, calling it 3W plus 4 is infinitely better than calling it L. It's all about having one variable. Let's see how this works on a harder question. We actually saw this next question in a previous video where I showed you how to do it with an alternate math strategy. But now let's do it for real with algebra. Joe went to the store where cakes cost $10 and pies cost $5. If Joe spent $250 total and bought 5 more pies than cakes, then how many cakes did he buy? Press pause, give it a shot. This incorporates the concept of widgets from the last video, taking a number of items and multiplying it by the cost of each item. So if we called the cake C and the pies P, using the price for each, we could say 10C plus 5P equals 250. And that would be fine. However, you can't solve an equation that has 2 variables. We need to think a little more creatively. So let's talk about that. If we let the number of cakes equal C, then what's a really good name for the number of pies? We could call the number of pies C plus 5. They tell us there are 5 more. That way, both terms have the same variable. Now that we have that, think about how you could rewrite the new expression. So we can take our new name for pies, c plus 5, and plug it into the expression we already have. 10c plus 5, parentheses, c plus 5, equals 250. And if you were to distribute that through and then isolate the variable, c would be 15. Again, notice the common theme. Instead of using two variables, we're using one. By the way, that last question could have also been done with a system of equations. Totally fine. And the next question can as well. Many questions could have many approaches. But let's just stay on the topic of let statements for a moment. Let's give this one a shot. Roger buys 10 frozen meals on his grocery trip. Some are chicken dinners and others are shrimp dinners. Chicken dinners are $5 each, and shrimp dinners are $7 each. If he spent a total of $62, how many chicken dinners did he buy? Think of the widgets. You're taking the number of items and multiplying it by the cost per item. So we could say 5c plus 7s equals 62. But remember, we have more than one variable. How can we rewrite that? Give it a try. Let's use that piece of information that there are 10 total meals. That means the number of chicken plus the number of shrimp would be 10. We can express this as c plus s equals 10. But remember, we're trying to get c all by itself. We want everything in terms of c. So, what's another name we could give to s, so to speak? Subtracting the c, we could call s 10 minus c. That's another name for the shrimp. 10 minus the chicken. Now that we have that, we could sub that in to our original equation. So, 5c plus 7 times 10 minus c equals 62. And before going any further, notice why that's better. Now we have one variable. Combining like terms would give us 5c plus 70 minus 7c equals 62. Moving everything around, negative 2c would equal negative 8, and c equals 4. The answer is 4. Let's see how this comes up on a trigonometry question. In the triangle LGM, the value of L is x degrees. If the sine of x is 5 over 7, what is the cosine of 90 minus x? This one's a little harder. Press pause, give it a shot. What does it mean that the sine of x is 5 over 7? Well, remember SOHCAHTOA. Sine is opposite over hypotenuse. And they tell us angle L is really x. That means the sine of L is 5 over 7. So labeling those sides, 5 and 7, it means that bottom side, MG, would be the 5, and the hypotenuse, LG, would be the 7. Now comes the hard part. What do they mean by 90 minus x? We know x has something to do with the angle measurement within the triangle. So let's play around with what we know given a triangle. It has to add to 180 degrees. So we could say L plus G plus M is 180. And we know that M is a right angle. So we could say L plus G plus 90 is 180. Moving over the 90, L plus G is 90. And now look what happens if we play around with these terms a bit. Moving over L, we could call G 90 minus L. And they tell us that L is really x degrees. So instead of saying 90 minus L, we could now call that 90 minus x. G is really 90 minus x. So before we proceed, that's kind of like a let statement. They don't want to call angle G, G. They want to call it 90 minus x. Now we have both angles in terms of the same variable. So let's put all of that information together. Asking for the cosine of 90 minus x is really like asking for the cosine of G. Again, using SOHCAHTOA, cosine is adjacent over hypotenuse. That means we need mg over lg, which is 5 over 7. The answer is 5 over 7. Let's try one more. In the right triangle above, hypotenuse ER has a length of 17. How could you represent the length of ET? Press pause, give it a shot. This question isn't blatantly telling you, but they want you to use sine, cosine, or tangent to manipulate the ratios. Which one is in play? Well, in terms of 25, we have the opposite and then the hypotenuse. That means that it's the sine that we want to use. So sine is opposite over hypotenuse. Using these numbers, sine of 25 would equal x over 17. Isolating the x, you'd multiply the 17 to the other side. Sine 25 times 17 equals x. That means we could represent the side ET as sine 25 times 17. Notice they don't want a numeric answer. they want an algebraic answer. Just like a let statement, you want to call one thing a name with a variable from something else. So, let statements can be challenging, but with practice, you start to get the hang of it. Again, the big theme is you want to use the same variable across the board for any different terms that you have. I hope you found this video helpful. Leave a comment down below with any questions you have regarding this topic or topics you want to see for the future to help you with your prep. I appreciate your support. Thanks. And remember, plan your work, work your plan.